brought to you by Campbell.
Hello.
Hey everybody, how y'all doing out there?
Well, I did tennis this morning.
I wasn't talking to you, I was talking to them. Right there. You just want to know, where are you? You over there? Okay.
I'm over here, yes.
You did tennis this morning?
Yeah, I did tennis this morning, so I'm doing good. How are you?
Are you a big tennis star?
No, not yet.
No? Alright. I'm doing pretty good. I'm ready to write some code and get into this. I've been basically on hold for a little bit, and now I'm not on hold anymore. It looks like my volume's just a little bit loud. Let me turn this down right there. Music Soda says, "Are you for real? Are you for real?" Nobody's for real in this show. Let's go to Campbell's machine.
Okay.
Let's do a little thing we say. What happened last time?
What happened last time?
Voiced by Campbell's sister. All right, switch over to your machine. You want to take us through it? Show us what's going on?
Yeah. So last time we were working on the Sudoku solver, and well, we added this button. I think this was last time. We added the button where you can load in a game. This is a kind of a game that we had already, and then we made it so that you can hit solve, and all of these notes will appear. So these are what numbers can go where, basically.
Based on process of elimination.
Yes, pretty much. And then if you hit solve again, it will put in the numbers that are where there's only one number. Oh.
Oh, got echo sound.
Huh. I don't hear that.
These are sound echoing. Let me try. Let me try that. Does that solve the echo at all? The sound is broken, that's for sure. Sound is broken.
So, for example, here.
Wait, hold on 1 second, Campbell.
Yeah.
Let's see. Do you have your mic on in our Skype call? Can you turn that off?
Yeah, I do. Okay.
Turn that off, and that might fix it. See if that fixes it, kids.
Okay. So for example, this 2, right here where there's a 2, it would put in a 2 here if I press this button. So yeah, see there. And then now there's only 1 9 here, and there's only one here. So 1 9, and then there's also a 4 here. Just a 4, a 7 here, and a 1 bit there. So basically, those numbers will be filled in. I might have missed some, but... And then just does that on and on and on and on until, yeah, it's fully solved. And so what I want to do today is make it so that, well, first of all, we can't edit the ones, so, here, wait, let me show you. We can't edit these ones, the ones that we've already put in once we've hit solve. Once. Or twice.
We want to be able to lock those down.
Yeah, so we won't be able to edit these. And then, I also want it so that, we want it so that, when, once it's fully solved, like this, or even if it's not fully solved, Oh, okay.
It seems to take a while to load the game. I don't know why that is. I noticed that too this morning. Okay, hold on a second. I'm going to listen to myself while I draw on the string. Okay, hold on a second. I'm going to listen to myself while I draw on the string. Okay, hold on a second. I'm going to listen to myself while I draw on the string. That's weird. It's like the mic isn't working. Check, check, check. Check, 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 check. I'm seeing levels. I see levels. Hold on a second. Let's go and listen in again. Hold on a second. Let's go and that sounds better. Again. Okay, I think it's fixed. Better. Okay. Not sure why that was the case.
And then maybe I think also if we try to put in here, if we try to put oops, wait.
Go ahead, Campbell.
Right
sorry.
In here, if we try to put any number that isn't 2 or 4,
like a 5 or something.
Show that that's a wrong number.
Yeah, what I would like it to do in this space, Campbell, is make the background of this square red and the background of any conflicting squares red as well.
Oh, yeah.
So you can see the problem as you create it.
Yeah, okay.
Mystic Soda is asking, shouldn't the solve button fully solve the Sudoku puzzle? Do you want to answer that, Campbell? Do you have any thoughts on that?
We could make it do that, but then also, what if like you just want to have like a small hint, like just to see kind of like where you're supposed to be heading. Right.
The solve button is at this point, it's just it's reflecting our algorithm so far. Is essentially what's happening. Our algorithm is super simple, which is find all of the ones that are already filled in every row, column, and block that intersects the square we're at, and remove those possibilities. So we just have these notes remaining. That's our first step.
And then we also have a clear notes button that clears it all. And what if maybe if wait, here, let me just.
Yeah, Mystic Soda, I agree with you. Let's create a hint button, which gives hints. All we have to do is rename solve to, hint or next step or solve one. But I do like it right now as we're developing the logic. I like being able to click it once at a time and seeing how we're going forward.
Yeah. So. And then we might also, like, if we have no values in any of these squares and we try to hit solve, we might make it so that it says something like, there are no characters to solve with, or something like that.
Sure.
Maybe.
We could do that. Okay, what do we want to do first? So let's switch over to my machine. I got kind of a list of things here. I've got some notes on advanced logic here, but one of the things we noticed is there's a precision click required to edit.
Oh, yeah.
You want to demonstrate that?
So if I try to click here on this square, it won't show the caret. It's only like in one specific area.
You have to be right in the center. Yeah. What happens if you try to solve an empty puzzle? Asked Mystic Soda. Yeah, it's got some problems.
It shows, pretty much every number, or it tries to.
Yeah, the notes are all filled out. We're only showing the first, 4 or 5 or whatever of those.
Yeah.
So that's what's happening there.
The first 4.
Okay, but solve it, says Mystic Soda. Yeah, I suppose we could do that too. Of course, with a totally empty puzzle, there's like, I don't know, a trillion different solutions or something.
So many.
We can edit squares that already contain values from a loaded game. You want to demonstrate that issue?
Oh, wait, what was it? Oh, yeah, we can edit them. So if we load the game, and then we can edit these values.
Right. So I kind of feel like the UI needs to have a locked state so that when it's loaded, we're able to lock these squares. Does that make sense? And so there's a checkbox up here that says locked that we have for testing, so we can unlock it if we want to actually change the values. Does that make sense?
Yeah.
But otherwise, and we might want to add a clear game button too. Something like that.
Yeah, okay. Okay.
We might also have buttons for load game, load easy game, load hard game, load medium game.
Maybe.
Okay. Yeah. And we want to highlight the conflicts, which we already talked about.
We want to what?
Highlight the conflicts.
Oh, yeah.
Which we already talked about. So precision click required to edit. You want to go after that one first?
Sure.
Okay. So let's figure that out. I think the problem is in Sudoku square XAML. Not the .cs, but the one to the right of that. Yeah, that one.
Okay, wait. Let me just... Oop. So we're looking for the text box width.
Right. I want to see if this text box value, see what its width is. Do we ever set it? Because if we don't set it, keep going over that way.
I don't think we do. Yeah,
doesn't look like we set it. All right, so I think what we do here is we say min width, and we give it a nice fat number. If you take off caps lock and type in, I think MW.
MW.
And then a number like 50. I think Coderish will fill that up for you.
No.
Try MNW. It could be too that you don't have these templates.
NW?
But then the caret's got to be at the end of the line. No? All right, just type in, get min width. I think we already reported this last time that these templates were not in there.
Oh, oops. That was not what I wanted.
Min width didn't seem suggested, which means maybe we missed it. It is on the line. Try again, hit control space. Nope, there it is. All right. Min width, set it to 50.
50.
Save it. Run it. See if that fixes our precision click problem.
It appears to have.
I don't even see the caret though.
No. I'm clicking everywhere and it's not.
So it didn't solve it.
It actually made it so that we just can't click anywhere.
Can't click.
No, I'm clicking a lot, and it's not showing the carrot.
Yeah, it's not showing the carrot at all. Okay, interesting.
Did we make it too thick?
Maybe, I don't know.
Wait,
I'm going to
wait,
immediately
wait. Can I
change it
see
to
something?
25.
I just want to see. Oh, why isn't it showing?
It's not showing it because you're running. If you want to see the value, you're going to have to stop the app. Visual Studio does not show you the designer when you're running.
Huh.
I know, not my favorite choice.
Yeah, it appears. Look, wait. It looks like. So is this the text box?
Yeah, I think so. That looks like it's it. It looks like it's okay.
It appears,
Whoa.
Oops,
Don't
sorry.
do that. Hit undo. Yeah. Let's go back. Let's change min width to 25 and see what happens. And then we'll repeat it all one more time. Did you change it to 25?
No, not yet.
Go to line 15, hit end key to get to the end. It's much faster. Practice that. Hit the end key. Yeah, your finger should be over there on the arrow keys and the end keys when you're not typing in things. Okay, try 25. All right, let's see what happens. Save it, run it.
Maybe. Okay, wait. Now, let's see. That appears to have fixed
That
it.
works, but the 50 doesn't. Let's change it to 40.
Oh, wait. Oh, okay. So there is a limit on it, but not by much.
Right, because it's 25
Yeah.
only. Change it to 40. I'm really curious as to why it stopped working. That doesn't make any sense to me if that's the only change we made. Close it down, change it to 40, and save and run.
Oh, wait.
Are you clicking?
Yep. Okay. So 40 works as well.
This makes sense. Change it to 50. I want to verify that what we saw was really a problem. What is going on when that's at 50? Click it. And it fails now?
Yeah.
You're
Wait,
clicking?
I want to see what
Tell
the
me when you're
limit on
clicking
this
so I
is.
can
Okay.
I know because I'm just seeing the mouse hover over it. So say I'm clicking if you're going to click
All
it.
right.
Okay. Cool. Save and run.
Nope, same effects. I was clicking. I'm clicking right now.
Nice. I love hearing you say I'm clicking right now. That totally makes it obvious that it's not working. Okay, cool. Close it down. Change it back to 40.
What about 40? I just want to test to see what the limit is. Oops.
Use a
not
binary
that.
approach then. Go to 42. Take half the difference between 40.
I think 43 because we know
Yep.
that 40 works.
That's fine. Save it. Nice. So fastest way to find a number is a binary
Yeah,
approach to
okay.
it. 43
okay.
works.
Yep.
Can we do one
43.
more thing? Can we change the...
I'm clicking, yeah. Okay.
Can we do one more thing? Can we change the text alignment to be centered on this?
Yes, can I test just to see if the limit lies at 43?
Yeah.
Oh, no, it's 44.
You know what? I think I know what's going on. Let me
Yeah.
show you what I think is going on. I don't think that it's not working. Watch. Change it to 50. Save it. We're still running? Look, it doesn't look like there's a carrot here. I believe it's behind here and we can't see it. Hit a number and I bet we see it. Right in the last square I clicked. There it is right there. See? So check this out. If we keep it at 50 and we then change instead to say, let's see if we have a text alignment on here. Text alignment, set it center instead of left. Now run it. And now I bet the 50 works.
Uh-huh. Yep, it does.
Okay, at least now we have a logical explanation for what's making sense. It was so big, Campbell, the other controls, the other squares were hiding the flashing carrot. That's what was happening. But now we've got a nice...
That is interesting.
What'd you say?
That's interesting.
Yeah, it's behind because that's the way WPF works. It stacks things up on top of each other. Okay, so we can cross that off of our list. Let's switch back to my machine for a second. Precision click required to edit. We're done with that. We fixed that bug. We can edit squares that already contain values from the loaded game and highlighting conflicts. I'll let you decide which of these two we're going to work on next.
let's just go in order. Can edit squares
Yep.
that already contain.
All right, so
it's here.
go ahead.
Right? This is the loaded game that we have.
Yeah, that's one of the games, and the other one
This is the other one, yeah.
We've got one called Easy Game and one called Hard Game. If you put the caret on Hard Game and tap to Nick's reference on it, you can see where we actually load it. Right there in button test click. So I think I added this line of code after we stopped the show. Look at the line of code right above. See that 257?
Yeah. So if we're holding down Control when we hit it.
Yeah, we load the hard game.
I don't remember you writing this.
Yeah, that's what I'm saying. Is I think I did it after the show. I think you walked out and I added this line of code because I wanted to be able to do it. Let's test that right now. By the way, let's hit start and hold down the control key and choose setup game.
Load game. Yep, this is a different game. I think this is the one we can't solve yet. Yeah.
Right. So we get to a point and we can't solve anymore with our current simple approach. We're going to take it to the next level here. Whoops, sorry. There's Campbell's machine right there. My bad on that. Go ahead and do it again,
So,
Campbell.
right
Load the
here-
regular game.
Oh,
Show the
okay.
difference. Load the regular game.
So this is the regular game. Wait. This is the control game.
Yeah, that's
game.
the hard game.
And then if we hit solve a bunch on here, it stops being able to solve at one point because it doesn't have enough one characters.
Yeah, our current solve algorithm needs see the 5 7 those two 5 7s right there.
Mhm.
It needs something. It needs just one of those notes to be their one number, and then it knows how to solve it. By contrast, show load the regular game, load the easy game, and show how we solve. And before you hit solve, see the number 4 and the number 8 up at the top right.
4 and 9 and
Yeah,
8.
all those are going to be filled because we know there's only one possibility there.
Yeah.
And that's how that's working. Okay?
Yeah. Okay.
All right, so we can edit scores that already contain values from a loaded game. So what we want to do is...
We might want to make like a lock method, maybe.
Yeah, let's do this. I'll tell you where I want to do this. I want to do it over here in our Sudoku square. I want to create a new property in here. Well, we have a property called lock. We already have that. What'd you say?
I did not remember that.
But it's not doing anything when we set it. We could create some setter code here that does something. I think I'm going to do this because I think there's a couple ways to do this, but I'm going to choose convert to property with backing field, which is going to turn it from an auto-implemented property to something that looks like this. Then these are like what we call simple accessors right here. I'm going to take those and I'm going to expand them right here. So I haven't changed any code. We still have this property called locked, but now I've given it a backing store. And the value of the backing store is now I can come in and I can introduce a setter guard clause here. This is also code rush, okay? A setter guard clause just guards against this code executing if there's no change in value. In other words, if I set lock to false and it does something like it maybe plays an air horn sound, like that, and then I set lock to false again a little later, if it's already locked, it won't go down and play the air horn code, wherever that is here.
Okay.
See what I'm saying? Because what does this do, Campbell?
That returns if locked or true.
Right, if locked is true, or if locked is the same as value that's being set, we get out.
Yeah. So if lock is true and we're trying to set it to true, then...
Exactly. Value. Where's value come from? There's no parameter here called value. Where's it come from? What magic is going on here?
That's just a C# code thing, right?
Right. It's the value that's assigned to lock. So if I set it to false, value will be false in the setter. It's only used in the setter. There's no declaration because we're trying to keep things simple.
Okay.
Right? Because if we didn't, we'd have to maybe do something like this. Value, and we'd have to say it's a bool. The syntax for C# might look like that. Do you see what I'm saying?
Yeah.
And then it would be clear where it's coming from, but that's not the syntax. Value is just given to you automatically.
Yes.
Does that make sense? Any questions on that?
No, I don't think so.
Okay, cool. So...
Wait, how does it know? Well, locked will always be equal to value, right? Oh, so it's a
No,
constant.
locked is not equal to value until this line of code.
Okay.
If we never hit that line of code, locked will never be equal to value, or will never be set to whatever's inside value. It could be equal because it's a Boolean at some point, right? Just like a stopped clock could be right twice a day. But anyway, there's locked. But now we can do something when it's different. And what we might want to do is we might want to go to the text box and we might want to do something like this. And this is kind of like an old school way of doing this. I'm teaching the old school way to do this first, and then we'll do the new school maybe tomorrow.
Okay.
On tomorrow's show. I'm going to come into that TBX value. That's my text box out there. I'm going to go to my foreground property, and I'm going to set it equal to a new solid color brush. That means it's not a gradient.
Yeah.
And I'm going to go into my colors, and I'm going to pick a color like gray. Like that. If it's locked. Okay? Otherwise, if it's not, I'm going to set the foreground color to black. Does that make sense?
Okay.
Or maybe blue. I don't know. We could play with this. Do you
We
want
might change the gray color to something more different than black, maybe.
Sure. You got it, man. What do you want? You
I
pick. Pick your color right there. Just make sure you got contrast against the white.
Yeah, that's the hard thing. Maybe it is gray that we want. Well, wait, can I see?
Maybe a little bit of saturation. Yeah, look out, Campbell. Campbell, look out.
Uh-oh.
I don't know how they got here. Look out. Oh! The show.
Pudding.
Kids code, says pudding.
What about a color like that?
Let me see. Yeah, that's what I'm thinking. A little darker, maybe a little bluer. Just a little bit bluer and a little bit darker. Oh, look out. Cody Gorilla's here. Cody Gorilla's my show. It's Cody Gorilla's show. There he is right there. Normally, Fred is hiding Cody Gorilla, but not today. Cody Gorilla, put on some pants, man. Come on. Okay. All right. So anyway, back over here to Campbell's machine.
So something a little bit more.
I would drag it to the right and a little bit, and down just a little bit. Get it a little, yeah, right in there. Play in that space. See what you think. It's hard to see it against white.
Maybe?
Yeah, try it.
Okay.
Okay. Cool. Hello, Murky and Campbell. How are you doing today? Campbell, what's your take on how you're doing?
I'm doing pretty good. I just had tennis this morning, so.
Tennis this morning, we fixed a bug.
Yeah, we did.
We're doing good, I think,
bugs,
so far.
Did we not?
What?
I thought we fixed 2 bugs.
We fixed 2? I think we fixed just the precision click. We're working on the second one right here. Can edit squares that already contain values from a loaded game. So we want to be able to lock those, is what we want to do. Oh, there's one other thing we want to do if it's locked, Campbell. Let me come in here. Let me add block delimiters because I want to do 2 things here. I don't have just a child statement anymore. I want to come in here, TBX value, and I think there's a read-only property. Is read-only. See that?
Yeah.
What am I going to set that to right there if it's locked?
Equals a true.
Yeah, so I type in equals T like that. Coders will expand that as a template for me. I can take it, come down here. I can remove that, hit F space, and Coders will expand that as a template. Okay, so now it's locked or not. All right, cool. So we have locked apparently working, but we need to lock it.
Yeah, when we load the game.
A real quick way to test this, Campbell, is just add another button here. Come over here, type in B for button right there. I'm just going to call it button 1 because I'm going to delete it in a second.
Yeah.
We're going to call this lock, or maybe toggle lock, like that. Let's give it a click event handler. See it there? New event handler. And then somewhere in here we've got the selected square, as I recall. Thought we had something that said selected square. I don't see it at all. Whoop, right there. We've got this thing. So what I would do is this. I would say, hey, if that's not null, then you write this line of code. What are we going to do to lock it? Or toggle its lock. We want to toggle its lock. My apologies for that button 1 click name. That's a pretty bad name, but you're in a method that's supposed to toggle it. So, meaning if it's true, set it to false, and if it's false, set it to true.
Okay, so wait.
There are a couple ways to solve it, so you can, whatever way you want to do, whatever way gets you the code fastest, try it. Just a reminder, your selected
Okay.
square should be the Sudoku square that we just added, that we just modified the locked property on. It should be of that same type.
Wait, what do you mean?
Well, let's have a marker here for a second. Let me show you what I'm talking about.
Sorry.
What type is selected square is my question. Whoops. Let's drill into it right here. You can hit F12 to jump to it. It's of type Sudoku square. That's where we were right over here in this class with this property called locked. We just added this code to Sudoku square. That's what type this is. It's of type Sudoku square. So what are we going to do on this line right here? Yeah, I see where you're going. You're kind of going for the type, but it's not the type. We want to go after the instance. This is kind of where like a new kind of understanding the difference between like an instance and a class for new programmers is kind of like, it's kind of a thing you kind of got to wrap your head around. It's not the class. You want to go to the instance. What's the instance?
It's Sudoku square.
Nope,
Well.
that's the class. No, go back up and take a look at it. I don't think so.
No. Look.
Show me where you think.
Well, first of all, that's the class.
Yes. The instance is not here. The instance is over in main window. Look at main window. See that selected square right above? I asked what was that type, and I drilled into it by hitting F12. That
It's
selected
of type-
square is of type Sudoku square, but that's our instance right there. Does that make sense? Instance, it's the thing that's alive while we're playing the game. So we're tracking which one is selected.
Huh. Okay.
So let me give you a hint on this. Yes, it's going to start off with selected square. So what are we going to do to toggle selected squares locked state? Nice. C# is too abstract, says VI.me. Too abstract.
Oops.
Hold on, move the mouse on your machine a second. Just close that down. All right, so what do you want to set lock to?
Well, the opposite of whatever it is right now.
Okay,
Right?
do you know how to reverse a Boolean? Do you remember what operator we use?
Is it this or is that no? That's
Nope,
something different.
that's mod. It's the exclamation mark. Exclamation mark means
Oh,
not.
right. It means not. Basically.
VI.me says any programming language is fine to start learning programming. It's a bit too abstract. But now what do we want to take the not of? Value doesn't exist here because we're not inside the property. So what, you just tell me, Campbell, what do you think it should be? What are we taking the opposite of?
Well, whatever it is.
Okay, so how do we get whatever it is?
Uh,
I feel like you're almost there. Just think about it for another second. If I wanted to find out what the value of selected square.locked was, how would I find it out?
well, oh, wait. Is it just locked? Oh, wait. It is equal to not selected square dot locked
Perfect.
or dot locked.
Yep. That'll toggle it. And you need a semicolon at the end of that line. So take a look at that. So that's the line, right? So take a look at it. Take a step back, take a breathe, relax, right? That's the line that's going to turn that on and off. So now what we want to do is run it and now
And then
put it in a square with a number in it and then click on toggle lock and see what happens. Do we see a visual change?
Yeah. It's not huge, but it is there.
And can we edit it now? The question is, can we change the font?
No, there's no caret that appears there, even if I try to click on it.
Nice. Now choose toggle lock on it. Now can you go back and edit it?
Yeah.
It's a discussion out in the chat room. C# C++ is verbose and tedious, but abstract. I don't know. C++ is like, makes my head spin in terms of the things you can do. I'm assuming more abstract means lower on the level table. Yeah, I think that's what Pudding is talking about. Yeah, I mean, he says levels of abstraction. Like C is pretty close to hardware, while Python, for example, is very abstract. Oh, interesting. You know what's close to hardware? Assembler, yeah. Python is super easy for beginners. Yeah, I have not looked at Python at all, almost. All right. So now you want to do something that automatically locks everything after we load a game. All right, so let's look at that and figure out.
Something that will look a bit
You don't want to, Murky? Yeah, okay. I'm good with that. All right, let's close it down and get to work.
Something that looks like that once we load the game.
Yeah, we want it to look like that. What are your thoughts on this, Campbell?
I think we might do a checkbox.
To do what?
That unlocks everything, every value there.
Yeah, or unlocks everything?
Maybe.
Yeah? Okay. Okay, good.
Something similar to this button, but it applies to everything.
Viami says syntax is easy. Higher level concepts are hard to grasp. Yeah, I think that might be true. Especially recursion is hard to wrap your head around. It's unlike most things we encounter in the real world that we need for survival. So we're gonna actually look at recursion, I think, tomorrow, Campbell. And tomorrow's gonna be mind-blowing day on the show. Viami says, I compile my own Python interpreter. Impressive. Okay, cool. What else do we need to do, Campbell? Coding Gorilla says, okay, I get what you're saying. I think for beginners, though, an abstract language would be better. Helps you get the fundamentals of programming. Yeah, flow and stuff like that without the crazy details of memory management, low-level crap like that. I agree with you, Coding Gorilla. In fact, let's put that up on the page right up here. Boom. I totally agree with you. One of my favorite beginning languages is that thing, I think it's called Turtle, where you just control a turtle and you say left and right and all of that. You're so far away from the code, from the machine, the hardware, that I think it's useful and easy to learn. But I didn't choose that with Campbell. I instead chose Unity to trick him, and then now I've moved him over into, we're in like raw C# and WPF today. All right, buddy, what are we doing?
Okay.
Ready?
Yeah.
What's our next step? What are we gonna do?
I think we make a new checkbox, just for right now. Oh wait, we should probably.
How about if we add the behavior first? Let's clean this up. Can we clean up our test code? Is that what you want to do first?
Let's just comment it out though.
Okay, get that extra line down at the bottom of it. Also comment that out at the end.
Wait, this?
Yeah, that one right there. That's also part of it. Okay, and then you want to go to the XAML, and what are we going to do in the XAML? Are we going to keep it?
Wait,
that button one? Might as well kill it. I think we can kill it.
Yeah.
Okay. All right, cool. So next we have to find, where do we have to go? Where in the code are we going to go to lock everything after we loaded the game?
We're going to go to, I think, here, or, wait, what do you mean? I'm not sure I understand.
Well, when we load the game, we want to make that choice. We want to modify everything. Biani says, one day you will have to go to the ground. Otherwise, you don't know how this abstraction is built and you write inefficient, unoptimized, and memory wasteful code. I would actually say there's a market for developers writing inefficient, unoptimized, wasteful code, and that they can spend their entire lives not knowing and writing and making a good living. I believe that's true. So yeah, and people like that probably don't want to go down to the ground. So, Cody says, I'm an old school C and C++ programmer going way back to the Commodore Amiga. Oh my God, I have so much envy for programming on that machine. It was so fun. It would look so fun to write games for in early PCs. So I'm well aware of how all that low level works. Yeah. All right, Viami is out there. Okay, so what are we going to do, Campbell? Oh, so my question is, well, how do we do this? We need to now lock everything, Campbell.
Huh?
We need to lock everything that we've loaded up, right? Describe to me in words what happens and when does it happen?
Well, it happens. What happens is we make it so that we toggle lock every value that there is, every square that has something in it.
Yeah.
And then when it happens is, I think, when we click the check mark on.
Okay, I want to do it instead just automatically every time we load the game. And then later I want to turn the checkbox off to enable it.
Okay.
That's what I want to do. I don't want to put a checkbox in yet.
And
because
then each time we solve as well, we want to lock those values, right? Or
no, I don't think so. I don't think we want to do it when we solve it. I think we only want to do it on load.
okay.
Okay.
Oh, also, every other time we hit solve, it just updates the notes. So if we were to toggle lock it each time for each thing that had a value, it would switch them on and off. Do you know what I mean?
Yes. No, I don't want to toggle it. What I want to do is I want to load the game.
Yeah, that's why
And
I'm saying.
right after loading it, I want to go find all the ones that have values.
Yes.
Because that's when we know the pieces that should be locked. After that, we won't know because somebody could have entered a number.
Okay.
And if they've entered a number afterwards, how do we know what to lock or unlock? So I just want to lock everything we're loading from the game. That's what I want to do. So the answer to my question of when is when we load the game. How do we find that code quickly if we're here? How do we get to that load game quickly code quickly?
Oh wait, we have to get to the code for it.
You can actually there's a trick you can do if you're back on the other side. You can double click you can double click something on here. What is it? That's it. Okay. So what happens here?
What happens here is down here, I think, we do the same thing as we did.
No, what happens? I'm asking what is happening right now. That's all I'm asking. I'm sorry, that wasn't clear.
Pretty much.
My bad on that.
Oh, what's happening currently?
Mm-hmm. Yeah, because we got to find the right place, and I don't think this is necessarily the right place. Is this it? What happens in button test at click? It's down a little bit. It's right there in the middle screen.
Right now, it's when we click it, it sets up the game that we.
No matter what happens, what method do we call from here?
I'm not sure.
No matter what happens in that if statement, what method do we call?
Set up game.
Perfect. Go into set up the game. We're drilling in. Okay? All right. What happens in set up game?
Well, we clear the game.
Okay.
Currently.
Not a big deal. We don't need to lock door because we don't have any data yet.
And then, I'm not sure what this code does.
That splits the game string into multiple lines. The /n is the end of line.
Okay.
So if you look at those game strings up there, let me move the mouse over to your machine a second.
Isn't it a new
See
line?
these?
Yeah.
It breaks these into all these different. Yeah. This is a
New line.
new line character, I guess, right?
And then down here, what we're saying is we add the values for each line.
Okay, go.
For each row, and then we increment the row.
Go to add values for line. What's happening in here?
What's happening in here is that we're doing the same thing that we were doing before, but with the column, right?
Going through each column. And what's this? What is this going on here and here?
Well, if we have a space, or wait, if the value isn't a space,
Right.
then we take its row and its column. So we basically find out which square it is, and we set text to the character to string.
Yeah, this is where we actually set the value from the piece we're loading. Okay. What type is this instance right here that I've selected? Do you know?
It's an array.
Well, this is the array, but if I include the indexing, what's the type of the piece inside that element, that row and column? What type is that?
I don't know.
Huh. Let's go take a look at what squares is. It's an array of what?
Of Sudoku square.
Does Sudoku square have a locked property on it?
Yep.
It does. So let me just add block delimiters here. What line of code goes here to lock it?
And then here we do locked, right?
No, you need to index it here. Just like you're doing in the line above.
What do you mean index it?
Index it means you put a value inside between the brackets to say which one you want to deal with.
Yeah.
If I have a two-dimensional...
Right?
Look at the line right above you.
Oh.
There you go. So you specify the row in this dimension and you specify the column in the other dimension. That's going to tell you which one of those we're working with. Now what do you say?
Selected square, right?
Nope. Selected square is a field variable on this class. There you go. Look at that. You found it. Good job. Right? What type is it? It's a type Sudoku square. Does Sudoku square have a lock property on it? It does. Get a semicolon right there, my friend. That is awesome. You did such a good job on that. I'm going to get you a party for that. Some amazing code, Campbell. You did it.
Okay.
There's a harsh debate going on out in the chat room right now over, how much we should know about the hardware we're writing for. Okay, so what are we doing? We're loading a game and checking to see if everything's locked. That looks locked.
Appears to be locked.
You did it, Campbell. You did it.
What if I... Okay.
Hit solve. And then one more time to get some values. Now try to change those values that have come in.
It appears that I can.
Yeah.
Yeah, I can. And then here we might lock
Of not touching a code base. You'll look at it again and you'll take a while to remember everything. No, I agree with Mystic Soda. It's got to be easy to read. Is it still Unity or did you switch over to WPF? Uh-oh, Coding Gorilla.
Yeah.
Coding Gorilla has caught us. We're in WPF, Coding Gorilla. We're totally in WPF.
I think we might lock it here as well, maybe.
Would you solve the step?
Yeah, once we're fully solved.
I don't know. I think we're kind of overthinking it because
Okay.
it's like but the cool thing about this is now, Campbell, look at this. We could add a new button very easily that clears the solution. Clears.
Ah.
Okay, so we got to clear notes, but we could maybe even tie it into clear notes. Well, maybe not clear notes. I don't know, but we can.
We can kind of hit. Wait, can I show you something? So if we solve this partially, if we hit load game again, yeah.
It just gets us back to there. Yeah, so we don't need the button. Okay, cool. All right, so now let's switch back over to my machine. Can't edit squares that already contain values from a loaded game.
Bye-bye.
We've done that one. Goodbye.
I like conflict.
I like conflicts. This is actually going to be fun. I think what I want to do here is I'm guiding it in this direction, Campbell. I want to kind of go over here. And I think I want to add a new property. And we'll call it has conflict. Were you going to ask a question, Kimmel?
Right now, we don't really have any code that detects if in that row, column, or... Oh wait, no, we do. Never mind. Okay. Okie dokie. Wait, no, we don't. We don't have code that checks to see if in that row, column, or block there is something that conflicts it.
I think you're right. I think we don't have that we don't have that really yet. We've got has conflict here. Let's do this though. I want to do the same kind of thing, right, like that we did here, up there. Like I said, this is the old school way of of changing the UI based on the code. Tomorrow I expect to show you the new way of doing it. So now what I want to do is I want to change it, instead of changing the foreground, I want to change the background. Okay?
To probably something like red. Maybe.
I'm 100% with you on this. I also want to see where else we're changing the background.
Here.
When it is... Oh, that's the background of the whole piece. I thought there was another background change, but it looks like we're not. Okay, cool.
Right.
Cool. What I love about C# is that you can write code exactly like in C if you really wanted to. However, you don't have all your mallocs, stack alex, etc. like in C. Yeah, you don't have those. Okay, so if we have a conflict, we're going to go with a red, maybe a lighter red, because we still want to be able to see the text on top of it.
Oh, right.
Okay? And then otherwise we set the background to what color?
To white, right?
White.
Wait. I think we might do something a bit darker than this, just
Sure,
because
you take it. Whatever you want.
that doesn't feel like error-y enough.
Okay.
Yeah, I think just a little bit darker.
Why are we on my machine? We should be on your machine there. Okay. All right, so there. Good. So now I got a property called has conflict. Do you want to just test it out?
Sure.
All right, let's do it. Create a new button. Whoops, that was a border. Create a new button. Come in here. Let's do this. Conflict toggle. btn conflict toggle. I'm going to give it a good name, even though this is just temporary code, and we're going to delete this in a second. Once you create an on-click event handler for it, you can double-click it, by the way, to do that. You can double-click the button up at the top. Fast way to do that. And now go ahead and write some code for me.
Okay.
That toggles conflict in the selected square.
So. What was the name for it that we had?
Conflict, I think. Conflicted. Starts with a C. Has conflict, my bad.
Okay. That's not. That's fine.
It's right at the tip of my finger if you want to look at what my finger's pointing at.
Okay. So it is that. And then selected square. Oops. Square dot. Okay. And then semicolon. Control S. Control S. Start. Also F5. So if we. Oh. It doesn't fully. It only does it with the text box.
Okay. It's actually, I don't mind it. It's not great, but it's not like the whole thing. Let's go ahead and change it.
Okay.
Let's go ahead and change it so it works the right way. It's only with the text box. Let's go look at the code. Maybe we shouldn't be messing with TBX value. Maybe we should be messing with another control. Which better control to mess with that's out here? Maybe grid 1, because it kind of holds the text box and the other piece.
Yeah, but I don't think. I think that will change the color of its current border, I guess.
No, I don't think so. It doesn't. Its border's not here. Its border's outside of it. See?
That's true.
The border's right there. Let's try it. Grid 1.
Grid 1.
Save and run. Yeah, just hit F5 to run.
5. Yep, that was it. At least I think it was.
Yeah.
If we hit solve.
Okay, cool.
Wait. Conflict toggle.
Yoja says good morning. Morning, Yoja.
Good morning.
Okay. Let's write some code to detect the conflict.
Okay.
We don't need that button anymore. We can remove it from our main window. .xaml. Nope, not that.
Yeah, I know. I'm just going to comment this out.
No, not that.
Nope.
That's code that actually works. We want that.
Okay. Okay.
That's when we set has conflict to true or false. It changes the background.
Oh.
We want to go
okay.
to main window.xaml. Yeah, delete that button. Excellent. And I think we want to. So let's kind of describe what we want to have happen. How would you describe it? What we need to write to make this work?
Oh.
When would it happen?
Huh.
When do we need to do this? When do we need to check for conflicts?
Well, if in any if it's row, column, or block has any number that is different from it.
That actually sounds like you're describing how to check for conflict. I'm asking when do we check for conflicts?
Every time we edit.
Every time we make a change. Exactly. So we need to check to see when something changes. When it changes, we need to go check for a conflict. Do you agree with that?
Yeah. Okay.
Okay. So whenever I make a change, we need to check for conflict. Let's see how we're doing that. I'm not sure. I want to look through the code and see how we're doing it. I think right now, out here, let's see. Set text. Got the set text method. Who's calling this? This is when we add the values. It's only there. We are just using whatever's part of the part that's whatever is part of WPF is just taking care of all of that for us. So it's taking care of storage and all of that. What we need to do is see this event right here, TBX value text changed.
Yeah.
Right there. We need to go into that and we need to do something. Here's where we set the value right here. And what I think I really want to do is kind of fire off another event so that I can then get that from out from over in this space is what I think I want to do. That's what I think I want to do. So I think I'm gonna make this super simple. I'm gonna create a new event up here. I'm gonna type in EV like this for event, and I'm just gonna keep it at event handler, and I'm gonna say value changed like that. Okay. Then I'm gonna hit the code rush key, and I'm gonna say create event trigger like this. That's gonna create a method that triggers the event. Okay.
Yeah.
I'm going to move it down to where we were setting the text. Wait, where is that? There it is, right. Right there. Put it right up there on value changed. Okay. And then what I want to do here is I want to check to see, I want to say, hey, if text is not equal to what changed, then I want to do that. And then I also down here, I want to say else if text is not equal to the space we're about to give it, then I'm going to come down here. So in both of these cases now, we know that the value has changed. We know the value has changed here, and we know that the value has changed here. So in both of those places, we can call on value changed. We can pass in ourselves and EAE for event args empty, like that. Okay, so all this is going to do is trigger the event. Okay, and we're triggering it at the right time when the value is in fact changed. Now what we can do is we can go over here where we are creating, somewhere in here we're creating these and initializing all of these. Here we go. So that's where we create them all. Now I want to create a method here called hook events. Like this. And let's declare that. Then I want a for loop that goes, I'm going to have the iterator variable be row. I'll call it row. It's going to go from 0 to 9. Meaning it'll really go from 0 to 8. Does that make sense?
Yeah.
And then inside of there, I'm going to have something called column.
So it will have 9 rows and 9 columns, like.
Yeah. Oops, I meant to say 9 right there, and there.
Wait, okay. From 0 to 9?
If I say 0 to 9, if I say it'll go from 0 as long as row is less than 9, that means it really goes to 8. Okay? And so now I'm in here. Now what I'm going to do is I'm going to say squares of row, comma, column, dot, and then I'm going to find that event that I had. I'm going to just tap the control key, hit E for events. Maybe I got to go in the hierarchy on this, go only to the Sudoku square, and then now go back in and hit tab E, and there's value change, the one we had. I'm going to create an event handler. Look at this. I want you to actually do this. Type in plus, equals, and then tab. This is for hooking up events in the code. And now hit the tab key. See, it says press tab to insert. Look at what that's Visual Studio right there. Look at what it just did. So we're going to call this Sudoku square value change. And when this happens, we know a value has changed.
Yes.
Okay? Now, when we load it, what's going to happen? Our value is going to change when we load it.
Wait, when we load it, yeah,
I think we're going to get value change happening, which means we're going to, every time this comes, we're going to say, oh, something changed. When we're loading, we want to not do anything. So
okay.
I need to create a field variable that I'm going to set when I load, and I'm going to clear it when I'm done loading.
Okay.
Oh, we're going to learn about something new too, a cool new code structure called try finally. Let's go find our load. Add values for line. I'm pretty sure that's it, right? Set up game. So here's what I'm going to do. I'm going to select this code that I want to protect.
Yeah.
I'm going to hit the letter F. Go ahead and try hitting the letter F, see what happens. I think there's an option we need to set up. No, nice. Okay, take a look. CodeRush adds a try finally around it. What that means is it says, hey, try to do this code, but no matter what, when you're done, execute this.
Okay.
Does that make sense?
Mm-hmm.
Try to do this, but no matter what, make sure you do this line of code before we get out, even if there's an exception. So what I'm going to do at the top of this is I'm going to say, hey, even if there's a return, if I said return right here, it's still going to execute this line of code.
Okay.
Does that make sense?
Yes.
It's an awesome, awesome structure. So we're going to come up here and we're going to say, hey, we're loading game. Everybody chill. We're going to set that equal to true. I haven't declared it yet, so I'm going to come up here, type in VB, variable type bool, paste it in, right? Copy that to clipboard, come down here, type in SF. You do it. SF and then space means set to false. What's on the clipboard?
And then it will do whatever's on the clipboard.
Yes, exactly. See it? Now, hit Control End to get the bottom of the file, because that's where our other piece is. We're going down there. And see, or actually, you can hit escape. See the red marker, that red triangle? Hit escape to jump right in there.
Escape.
One more time. There you are. You're right in. Just scroll up a bit because it's right behind your head. And now what you want to do is ask the question, hey, if we're loading, so say if,
loading game.
just paste it, it's on the clipboard. There you go. Then what are we going to do?
Then
I was going to say we don't want to do anything. We want to get out. I was going to say return.
Return?
Yeah. So just R space. R space is a CodeRush template which will get you a return very quickly. Okay? All right. So if loading game, then return. Cool. Otherwise, the value has changed. So what we want to do is we want to call check. So good. You write the function. You do it. Sorry, my bad. My bad. You do it. Create a function that we're going to call.
Else. We are going to well, here we need to
well, just describe what we're going to do.
we need to show the conflicts.
Good. So write a method called show conflicts, and let's call it. Get a semicolon on there.
Oops. 1 sec. Oh wait, does it not register it as a method?
There's a generate on there that's but go ahead, do it again. There you go. Get that semicolon in there. It's generally a little bit better. Okay, cool. You got this far.
we already have the code for it.
I don't think we have the code for it.
Pretty sure we do. Right?
I'm dancing, man. I'm not really paying attention to code right now. Just because you did so good in that last thing. You created that method. You declared it. Like we're practically done. Here's what we need to do.
We have the code for it. Remember when we set the color to red?
Yeah, no, we need to detect the conflicts.
Oh. Right.
You were telling me just moments ago that we don't have the ability to do that yet. Let's take a see look what's going on here. What's this get block doing? That looks cool. So for any row and column, we can get the column, row, and block for it. I'm going to need that. Okay?
Okay.
I'm going to copy that to clipboard.
Wait.
What?
I think there might be a slight problem with this. And that is that we have code elsewhere for get block that tells it basically only take the row and the column out by a certain amount.
I don't understand what you just said.
So, because the block...
Do you want to demonstrate it in the running program? Is it something that you can show visually?
Yeah, I think so. So, the block, it takes this right here, and it takes this row, the row up until this right here. Did you see this be gray for a second?
No.
Okay, and then it takes it to here, and then it takes each of these rows for just a
Right, it gets a block. It gets all 9 of those and says that's the block. That's what that method that we're looking at right behind
yes, but
it.
that... Oh, okay.
That's what that method that I copied, get block, does.
All right, wait, can I...
Take a look at get block and you can see it. This was a little crazy, what we had to do here. But we said basically, look, the top row is 3 times. We had to floor the row divided by 3. And what that does is gives us a number 0, 6, or 9. Or 0, is that right? Yeah, 0, 3, or 6 is what it gives us. And this does the same thing, 0, 3, or 6. So we get the top row and the left column. Then we iterate from the top row down 3 itself plus 2 more. And then we do the same with that left column to the right plus 2 more. See that C is less than the left column plus 3. So that means it's going to be C, C plus 1, and C plus 2.
Okay.
And then we're just adding them to an array. All we're doing is adding them to an array. We're saying that the array's 9 long and we're getting them back. That's what get block does. Okay? So these things we need. We need that and show conflicts. We know we need that. We're going to need this code as well because we got to go through every single one. Right?
Yeah.
You with me so far?
Uh-huh.
Okay. We're going to go through every single one. This is going to become column. This one's going to be row. Oops. Didn't see that on the side there. This one is going to become C. And this one is going to become R. And that should do it for us. Okay, cool. So now we've got a row, a column, and a block. Okay?
Yeah.
And we also can get the current value of the current square. So we can say squares of row, comma column. Nope, R comma C, sorry. R comma C. I'm just going to do that, and I'm going to say declare local on it. And look what it gives us. So basically, we'll call this maybe this square, and then we're going to compare it to all the other squares in column, row, and block, and see if there are any identical ones. You with me on that so far?
Yes.
The logic so far, what we're going to do?
Yeah.
Okay, so we're going to do that. So now what we want to do is say, well, what is this square's value? Do I have a get value on here? I think I do. I have a get value. And let's, whoops, I don't want to rename that. I want to, why isn't get value working? Whoops, my bad. Hit the wrong piece there.
Huh.
I think I've got the wrong piece in here. Let's tap control, go into hierarchy, look only at things in there. Get text is what I was looking for. Okay, so there's get text.
So what is this square dot doing?
What is, ask that again?
So what is, wait, here. how is this changing the method right here?
So here's what's happening. This square, this is just getting us a variable inside of that array. So we can reference it. It would be no different from doing this,
Okay.
which I could do.
Okay.
So now we got the text at this piece right here. And I think basically, look, hey, if the text is, I'm just going to go in and say, hey, look, if it is a null or white space, meaning it's empty or nothing, then we're going to just hit continue, which means we're going to go to the next C in this list. And once we get through all the C's, we're going to go up and get the next R. Then we're going to go through all the C's again. And then we go do that, we're going to go up, get the next R again, and then go through all the C's. So we're going to go through 9 times 9, 81 squares.
Oh, okay.
That's what a logic's going to do. So this is going to be the text of the square in each iteration. So this double nested for loop here is what gets us, each going through 9 different values is what gets us 81 combinations, right? We're going to get that text on each one. Hey, if we're null or empty, we're going to get out of there. Well, if that's the case, that might happen a lot. So I don't want to do all this heavy work until later, or what I imagine is heavy work, right? I don't want to get this stuff because if I can very quickly just find out if it's empty, there's no conflicts. And I can get out and I can just get it. The continue says, don't execute any more code inside this for loop. Come right back up into here.
Okay.
That's what continue is. It's like a return. A continue is like a return, but only for for loops. Does that make sense?
Got it.
Okay, cool. All right, so I've got column, row, and block now. So let's just take it simple. Let's look only at the column, right? So what I want to do is I want to do this. I want to now, I want to iterate 0 through 9 on the columns. Okay, so I want to do this, and we're going to say 0 through 0. When I say 0 through 9, I mean 9 were not included.
Yeah.
Like that. Okay.
So 0 through 8. Really.
Yeah, it's going to be 0 through 8 is what we're going to do, which is 9 values. And I'm going to rename this to be C check, C1. Call C. I don't know. I don't have any calls yet. Call check. We can call index like this. I know it's kind of big and weighty, but I'm trying to keep everything, give it good names. So now I'm going to go through the column indexes. And now what I want to do is I want to see, hey, if column of call index dot get text.
Column check would have been, or call check would have been just as long.
Yeah, would you like that instead?
No.
I don't know. Okay.
I'm just telling you, it's not. It doesn't really matter. It's the same thing.
Okay. If the column of the column index its text is equal to text, what does that mean?
It means that we don't do anything, right? We return, or
No, think about that. If I find the text of a block, a square, Sudoku square, in a column, and that text has got the same text as the text of the square I'm checking.
oh, then we want to show the conflict.
It's got a conflict, right?
Yeah. We want to change the background color.
So check this out. What type do you think this column of column index is right here?
It's of type column, right? Or wait.
It's not of type column.
Oh, it's of type selected square. Sudoku square, sorry.
Yes, selected square is the instance. That's exactly right, right? If I took out, by the way, if I took out the indexer here, Campbell, what type is column?
Column is of type array.
Right, is that 1-dimensional or 2?
It's 2-dimensional.
No,
right?
it's 1. If it were 2, it would have a column here. Great job, though, spotting that it's an array.
Oh, it would have a comma.
Yeah, remember? If it was 3-dimensional, it would have 2 commas.
Yeah, okay.
Right?
Okay.
All right? So
And
it's a 1-dimensional array. So with the index, it's now changes, instead of being an array of Sudoku squares, it's now a Sudoku square, which means, do we have a property here called has conflict?
Yep.
We do. And so we can say it's equal to true. Now there's one logical error. There's one logical error that we've got in here. We need to check for it.
Which is?
how do we know that the square we're testing is not the same
It's not
as
the
this
wrong-
square?
Well, we have to, I think, we have to get the row and column of this square, which we already have, right? Do we not? And then once we do, we just don't check for that, I think.
Right. We need to essentially find out where we are and see if it's the same. Now, if we get a column and we're iterating through these column indexes, this really is going down through its rows, is what it's going. That's really what it's doing. It really should be called
Row index?
yeah, row index or row check or something like that. Row index, I think, is what I'm going to call this, right? And so what we want to do here is we want something that says if row index is not equal to R, and I think that's going to work. I think that solves the logical error, because the row index, when we get a column, the row indexes are going to be 0 through 8
Okay.
for that.
Jenny 7.
Oh, Jenny 7's here, buddy. We need his help. And then
Letters!
it's Jenny 7, kid. There he is. Ah, look at our Kimball. It's just a mess in here. It's an intergalactic space battle. All right. So I think that might work. Shall we run it? We're not checking rows or blocks yet, but you want to run it? We'll just see if we can.
Check the column.
Yeah, see if we can do that.
All right.
Let's hit a run and see what
Let's do
happens. Do it. Do it for me. Create a conflict in a column and see if we can spot it. Ooh, I forgot to do something else though. We're only going to mark one of the conflicts. We're not going to mark the one we're in. Yeah, throw a 9 there.
9.
And now I guess you got to tab away. It didn't work.
Wait.
All right, we need to set a
What
breakpoint.
happens if I do? I think it was.
Let's set a breakpoint. Step through the code.
Okay.
Can't reproduce it. Let's go in the code. Show conflicts. Let's set a breakpoint there. Give me a 9.
9.
Tab away. Get out of there.
Oh.
Huh.
Oh, it's
Look at
never-
that. We're not getting an event fired. Let's see if we get the value changed. Try it again. Give me a value. Change the value.
What?
Well, change it to a 1 or something. Change it to 1 now.
1.
Nothing? Tabbing away? Nothing. Value change is not being triggered. We're firing it. Hook events. We're calling hook events. All right, let's go over here.
Wait,
Find out.
I want to see what it thinks loading game is, because that might be the problem. It might think that we're constantly loading the game.
I want to see if we get a breakpoint here. No, I don't think that's the case at all. Give it. I'm sorry. I don't want to dismiss you though. Give me one. Just give me a change.
Huh?
We are getting this. Let's step through this. Whoa, what's going on
Sorry,
here?
I
Oh.
accidentally hit 1.
Okay, let's hit F10 and just step through it. Hit F10 a bunch of times and see where the code goes.
Let me just scroll this down. F10. Ah! Wait, it skipped both of them.
I know what's going on. We're going to do this instead. I was too careful. What's happening is we were rechanging it if we typed in like 81 or something like that. That's what was happening there. I'm going to just take these two out and I'm going to put it in right there. Like that. All right, let's hit run. Continue. Okay, give me another change. Give me a 9 here. Oops, clear this checkbox, clear the breakpoint, run it. There we go, now we're in here.
Woohoo!
All right, let's clear the breakpoint and see what it does. Woo!
Oh, we didn't even have to change it.
All right,
So
get
what
down,
about-
throw a 6 in that other column. Okay, there you go.
What if I change it now here? And I change it? Oh, it doesn't clear.
Doesn't clear the conflict.
Even if I Wait, what if I make this non-conflict? So if I change it to, oops, wait, that's not good. That's not.
Wait, it looks like it added a 7 up above at the top.
No. It just that was already there. We just weren't.
Oh, okay.
busy. So if we change this to a non-conflict number, like 5.
Let's fix it so it cleans things up.
Yeah.
Okay, so if we go look at show conflicts, look, we're getting the square every time. We're going to iterate through every single square here. We might as well just at the very top of this say, hey, you don't have a conflict. Right there. Set a breakpoint here for a second. Make a change somewhere. All right, good. Hold on. And then that just gets it to recompile and then run it. Now try it.
Ooh, okay. Oops.
Oh, wait. I got a logical error. I got a logical mistake.
Yeah.
See this?
Yeah. We
So
need
it's
to
not
set
right-
that somewhere else because it's still not. It's
Yeah,
the
we could
highlighting.
have. Yeah. So we're gonna do this. We're gonna do this. Give me a second. I'm gonna do this. I'm gonna do 2 things. I'm gonna do this right here. Sorry, it's a little bit of a mess.
It's a wait. Can I do something really quickly?
Yeah.
Just
Okay.
just so that it's easier to read on the.
No worries. All right. So here's what I want to do. I'm gonna set his conflict to false here. I'm also gonna come up here and say, hey, if we got a conflict, then I'm just gonna continue. Because we don't need to do any checking. We've already checked it. Is that true? No, it's not true. It's not true. Because I might find a conflict in a column, and if I fail to check it, it might also have a conflict later on this row.
Oh.
So that's not true. All right, but I am going to do this. Now, the other thing we have to do too is we have to come in here, and we have to say, hey, let's do this. Let's create a new local for this. This is kind of where I was starting. I called this square. Coding really says, if you set them all to false first, how could that ever be true? The one that I had before. It could be true because of what's happening here. That's where I was thinking. It's this. Because we're kind of looking ahead in these spaces. If we have a conflict, then we need to also say this square's got a conflict as well. Okay? Does that make sense what I'm saying, Campbell?
Yes.
We need to mark both with it. Why am I having a problem here? Okay, there we go. It's okay.
gone.
All right, so let's run this. This should now, I think, work pretty well for finding only things in the column.
Mm-hmm.
And now change it to an 8. Sweet. Okay, cool. I love it. It's great.
Woohoo!
It's a great friend for solving Sudoku games, right?
Yeah.
All right, let's add on rows next. Okay? So this is my row index right here. I'm going to duplicate this, and we're going to change row index to col index. Okay? And we're going to change column to row. Like that. I should have changed R to C. Then we're going to do this,
Wait.
and we're going to say...
It was behind. Oops, wait. We should probably change this back to.
Okay,
Wait.
you want to do that?
Wait, that's a bit too small.
Campbell's got to make sure the font size is perfect for you.
110.
Don't forget you can control mouse wheel to get that very
right.
quickly change that font size. I like that.
I like that, yeah.
Okay.
121%.
So basically this is just like a 90-degree flip of this code, right? And that's kind of what's going on here. I just realized I can get rid of this block delimiters here to simplify that and do the same thing here because it's got only one child. So if the column index is not equal to C and row of column index at get text is equal to text, then we got this conflict. I think it's going to work. Save it and let's run it. And so now we should find conflicts within rows and columns.
Okay. So here, if we do a 7, what if we do one? Wait, I want to check something. What if right here we put a 6? It highlights them both. Okay, that's good. That's a nice sign. Or even 9.
Okay. Are you satisfied that that's working?
Yes.
What if we did this? We haven't done this test yet, but what if we put in like a 1 here and then another 1 down here? It finds the ones that we have as well, that we've changed. Cool?
Yeah.
I love it. It's nice. It's a functional. But we still don't have, like if I type a 3 here, oops, sorry, 6 here. I need an example.
What
1.
about, wait, what
Here,
about?
if I type a 1 here,
It doesn't change. It doesn't detect it.
it doesn't find that. Okay? You got to find that one. Okay, ready to do that one next?
Yes.
Okay. This one's a little trickier.
It is.
So,
Because it's not just in one direction.
yeah, so I'm going to do this. I'm going to say this is going to be the block index. And this is going to be block of the block index. But now what I need to do is something different here. And I think I've got a function in here called get square position. All right. So what I'm going to do is I'm going to use that method. This is not the fastest way to do this, Campbell, but it is yeah, it's a way to do it. So we're going to come in here and we're going to say out the block row. Say it's an int. Remember that syntax?
Yeah. Yes.
What does that mean when I've got out and an int there?
It means that you're sending that parameter. You're not taking whatever that's set to. You're setting it in that method, and then you're sending it out to that.
Right. Exactly. So now what I want to do is this. I just want to say, hey, look,
Whatever.
if block row is equal to R, that's the row of our current square, and block column is equal to C, then I want to call continue. And that's going to just continue through the loop. That's going to stop us. That's going to replace that other check that we did before, where we did this check here, if call index is not equal to C, and this one, if row index is not equal to R. I think there's a faster way to do it than calling get square position, but this is pretty easy in terms of lines of code. So it's just going to find out where that block is as we go through each one of those blocks inside of each one of the squares inside of that. Maybe I'll call this square index. Let's do that. Whoops. I might be square index. Like that. I think that's going to do it. Let's run it and see if that works.
Okay. I don't think it will. Maybe it will though.
Campbell's betting against me. Never bet against your father.
Mhm.
All right, so hit a 5 here. Oh no, wait, 5. Yeah, hit a 5 because we should see the other 5 light up too. Okay, oh, there's a 1. Nice.
Okay.
We think it's working?
What if we do a 5 here? Oops, wait. And then maybe we try another 5 here. Oh, that's a lot of.
All right, I think we did it. Cool?
Cool. There's just one thing that I think we can solve really quickly, and that is, wait, let me. So if I go from here to this, our caret is on the wrong side. Or it's kind of, we would have to move our fingers up to delete. Whereas I think if we can just move back and then hit backspace.
Do you want?
that's really it.
Okay, so we can do 2 things with caret. We can do, so there's something for carets. So let's talk about this for a second. Let's go over to my screen for a second here. Let me do this. I want to undo this, and I want to just cross these out so we know that we've done all these. All 3 of these we've done. Now, so let's do strike through. Boom. Done. Okay. Next, let's talk about carets and selections. This is actually something that took me years to figure this out. All right.
That's a weird spelling for caret.
That's how it's spelled. Okay, so let's do a couple things in here.
I'm glad it's not spelled like the food item.
Okay, let's get the letter A in there. Let's make it nice and big. Okay. So, and then let's draw a caret. What do we do with this? Is what I want to do. All right, so there's my caret, right like that. Too big. All right, so there's my caret.
Yeah.
So it's basically, generally the caret is described as an offset position, right? So if the caret is here, right on the left over there, right? Then we would call that essentially at position 0. Let's throw a text box down here as well. We're just going to say 0. So caret equals 0, like that. Right there. I want to make just a couple of these so we can kind of see these. Take a look at these. Okay, cool. Duplicate slide. Whoops, did I delete it? Duplicate slide.
That's not pizza.
What'd you say?
Then to not pizza. Not pizza is now following.
Oh, not pizza. I didn't see it out there. And then this one is going to be caret is equal to 1 right here. Okay? So that's kind of caret position right there. See what's going on there?
Yeah.
Right? That's where that is. We can also do a selection. And a selection, let's duplicate the slide. A selection has an anchor. And I'm going to kind of visually draw, I'm going to make the anchor kind of like this kind of a thing right here. I'm just going to do that, subtract that shape. Let's make it red so it's visually distinct. Give it a darker outline though. All right, cool. So there's my anchor, like that. And so my anchor and my caret can decide what's going on with regards to the selection. Whoops, not what I wanted to do. Just that one.
Oh, okay.
So now we've got anchor is equal to 0. Okay? So if I have anchor at 0 and caret at 1, that means as if I did this. I clicked on the left and dragged to the right. But I could also click on the right and drag to the left. And the caret's over on the left. Okay?
And they would be swapped, yes.
And that actually makes a big deal. In fact, if you look at CodeRush templates, let me see if I can figure out a template that does this for you. Maybe even the for loop one. Let's see what's going on here. Yeah, so look at this. See the word square?
Yeah.
So square is, hold on, let's stop the run here for a second so we get rid of these things. Let's zoom in on this. So take a look at square. Square isn't working because it doesn't exist. Let me create something that exists for a second so we get rid of all of that. I'm going to create a variable here.
Oh, wait, we're on the wrong screen.
Oh, sorry. Thanks so much. Good job, Campbell. Save this. All right, so here we go. We're going to create a new variable here called max and set it equal to 9. Okay. Copy max to the clipboard. Come down in here. Do a for loop. Okay, now look at this. If we zoom in on max right here, look at what happens. Max is selected, and the caret is on the left. Okay, could be on the right, but it's on the left. Why are we doing this in CodeRush is the question. Why are we putting the caret on the left? The reason is, here, let's go in and rename this a second. Let's undo it. Let's take our max and rename it to maximum value, like that. Maximum awesome value, like that. Let's come back in and do the for loop again. Now look at what's happening.
Okay.
Why is it on the left?
So that we can easily, I think, change one word at a time.
Well, if we start replacing, say we don't want it, we want to change something else. Let's say, first of all, the caret is flashing. So our eyes are drawn to it. Right? So our eyes are here. If it were on the right and our eyes were here and we started typing something in, watch what happens. Whoa! And now our eyes have to move all the way over to the left. See it?
Okay.
But because it's on the left already, if I type something in here like this, my eyes are on the left because that's where it is. And as I start typing, I'm good to go. See? I don't have that abrupt change. So that's what's going on there with that particular selection. So let's go look at how it runs and how do you want to change it. I want you to tell me where you want the caret and what you want it to do, and let's watch it, run it, and see what it does.
Bro.
Couldn't realize this is a cool story, bro. It's not a bad story. That better not be sarcastic. You better not be giving me a sarcastic clap out there. You running it?
I'm trying to get the font size back to normal. Okay. So I think I kind of want, since we won't have more than 1-digit numbers, I think it is fine if we have the caret on this side.
What if we selected it? We could also select it. So if we just
I guess,
tab,
but
it would
if
select it
it's
and we could
wrong-
immediately type something in to replace it. I didn't hear what you said.
Maybe, but if it's wrong, or even if it's just the selected square,
Well, tell me what you want, how you want to change it. One of the things we can do right now is if we tab into or move the caret into a place that's
Wait.
empty, we can type something in if it's empty. But I don't think we can if it's full.
something's wrong. It's not showing that this is the selected square if it's selected. Like if I use the arrow keys,
Oh, I have an idea as to why.
why?
Because it was problematic before, then we changed it back. And when we changed it back, we set the background to white, which means it hides whatever's behind it. I think we want to set this to null.
Okay.
I think that's the fix right there. Let's do that and get a breakpoint in here. Make some changes.
Okay.
Make some changes so we can get in there and get a conflict. Make some changes.
Oops. Sorry.
Breakpoint's already there. So like make a 5 and delete it. Make a 5 or make a 9. Put a 9 in there. There you go. Now just clear the breakpoint and run it. I just needed it. My change wasn't going to work unless we hit a breakpoint. All right, now hit run. F5 to run. There you go. Okay, now let's.
Nope.
Well, we got it. It's still.
Well, that was right. Oh no. Slight bug. If we hit load game when we have an error.
There it is. It's fixed now. See it?
Yeah.
It was that. That was the problem. You said slight bug. If we hit load.
There's a bug look. So if I have a 5 here and a 5 here, and then if I hit load game.
Oh, nice. Good bug. Look at that, Campbell. You found a great bug. We need to set has conflict to false on everything.
On load game.
Yeah, inside load game. So over here, we added some code at the very beginning. See that? I'm going to extract that into a method. Call it clear all conflicts. Because I want to call that same code when we load the game. What was the name of our method that loaded the game? Do you remember what it was called?
I think it was game loading. Is game loading?
Nothing with game loading. Do I have a load game? No, in fact, I only have a few things that have the word game in it.
Loading game. No, that's a boolean.
I can tap the control key and look only for methods. Right here. Like this. Looks like I only have 2 choices with game in it. Any of those ring a bell?
I don't think that's it. Wait, can I try something? I just want to see. What about load? Is it case sensitive?
No.
No. All right.
Let's go back to typing in game. Well, it's not clear game. What's setup game do?
Let's see. Oh, this is the one where we
Well, look. Look
Oh yeah,
what we're
wait.
doing.
Yeah. Okay.
Do you think that maybe this should be renamed?
Yeah, probably. To
To
Load
what?
game.
All right, fine. So load game. Now that we've got load game, I got to call it clear game. Guess what I'm going to do in clear game? I'm going to call clear all conflicts.
Conflicts. Okay.
Yeah, that sounds good. All right, let's run it and see if we can duplicate that bug. See if we fix that.
Load the game. 5, and then yeah.
Nice, much better, right? Okay, good. It feels pretty good.
There's also there might be one small thing. There might be one. If I hit load game, I have my selected square. I can't type anything into it though because the carrot isn't there. Oh wait, I've just lost focus. Never mind. That's not
Yeah, it's because you move switch focus away.
Else.
Okay, it's we were talking about anchors and carrots, and one of the things that you kind of gave me an idea, Campbell, and it's kind of like this. We run this. This is the thing I wanted to talk about here. If we load the game and we put if I just move around using the arrow keys, right?
Yeah.
If I'm here, I want to type something in, I just type it in. If I move down and then back up and I want to change it to like a 5, is that going to work? Oh, it does work anyway.
Oh, right.
Yeah, that's that code we wrote that said, let's find the change and make the change go. So it really doesn't matter if we select or not.
Oh, okay.
What were you thinking?
I can't change it. Oh, wait, no, I can't. Okay. Never mind. No, that's fine then.
All right, so we're good. All right, let's go back to our list.
I can also just, if I don't want it there, I can just hit space or any letter that isn't on the available characters list. I mean, sorry.
You can hit space, you said?
Space.
And that deletes
here.
it? Is that what you're saying?
Yeah, it just gets rid of it. So if I have focus here, and then I hit space, it gets rid of it. Or if I hit any letter that isn't in the available characters, like J or K, anything. Or even,
I wonder if we should allow that. If you hit it like any character that's not, should it really delete it? I don't know.
I think so.
Okay.
I think it's just because it's for ease of access. Like if you have a 9 here and you just want to get rid of it and you don't have your thumb on the space bar, you can really hit just anything. Or the majority of the things on the keyboard. Yeah. Okay.
Okay. Next, let's go switch over to my machine. Next, we've got some advanced logic we want to add in.
Yes.
So our strategy is this. Let's kind of just talk about our overall strategy for solving this. So we've got some logic that we're going to apply, and then we've got kind of what we're going to call a brute force. Maybe I'll call it recursion instead.
More or less. Brute force.
But this is going to be based on what's left. So logic, we're going to do a couple things. One is look for simple conflicts, which we found.
Yes.
And remove them. And is that the best way to describe it? What we're doing is we're finding and remove those as possibilities. And in fact, I think it's really important when we're talking about this here. This is probably even more important. Hold on a second.
Or maybe even remove those from the notes. Maybe.
Possibilities. Yeah, that's what I'm getting to right here. Possibilities for a square. So if you're a baby square inside of this, Campbell, and you haven't grown up yet, right? You're just a little baby, right?
Yeah.
You basically got, your possibilities look like this. One, hold on. Where am I? Right here. Your possibilities for the solution look like this. 1, 2, 3, 4, 5,
6, 7, 8,
6,
9.
7, 8, and 9.
Yeah.
That's what you could possibly become when you grow up,
Yeah.
right?
And then each time one of those gets taken away, so each time another square gets any letter that is that, or any number that is that's in that block, column, or row, then you cross one of those out.
Yeah. Let me just get kind of some colors right here. It's my baby Sudoku square.
Yeah.
And this is the possibilities for when it grows up, what it could become. So what happens over time? Over time, we might come along and say, well, you know what? 5 is not a possibility for you anymore. Okay? And what happens is we pare away from this list as we play the game. That's what's going on, right? And each time we kind of solve something, so we're really talking more about, it's essentially process of elimination approach is what we're doing, right?
Yeah.
In terms of that. So our strategies for solving, look at simple conflicts and remove possibilities. Maybe just say, remove possibilities that conflict with other squares in the column, row
or block.
All right?
Yes.
Logic. That's step 1. Step 2, we've done this. That we've done. Go after I want to call it the 2x2 rule. And I'll explain that in a second. Then go after the 3x3 rule. And then go after the 4x4 rule. Expecting more of these.
When it gets harder.
And I'm expecting almost none of these.
Yeah. Because
almost 0 of these. But they might exist.
So just in case.
And I think that if we implement these rules, we're going to be able to solve all easy and medium Sudoku puzzles.
Okay.
Then this is going to get us the hard ones right here. We're going to use this strategy afterwards, but we're going to go do these first. By the way, this recursion approach, Campbell, could work right now, but it's not what I would describe as fun.
Okay.
It's not what I would describe as fun because it just simply says, okay, here's the solution, and there you go. What I like about this is we can see it getting smarter. And I like this approach. And the other thing that's cool about this is that this approach allows this last one to be a small subset of the brute force. So instead of,
so it's
pursuing
a lot of brute forces.
Trillions of possibilities or whatever those number of possibilities are based on the
slow it down.
Starting set. What did you say?
Which will slow most PCs down. Or most computers
down. You could certainly use a lot of computing power possibly. So we're going to go after this. Let's talk about these rules. Here's the 2x2 rule. Right here. If I have 2 squares with the same 2 values in them.
And they're in the same row or column and block.
Or block, it can be any of those.
Yeah.
Then that means these 2 values cannot be anywhere else.
Yeah. So what anywhere else in that row, in those rows.
The row, column, or block.
Yeah.
Right? So if this is I'm just going to create a little red X. Here's what I'm going to do. Like that. So that means there's no 1 or 2 here, or 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 even continuing along, out over here as well. Right? Nothing along out here, nothing out of here, and the 1 or 2. Well, here we can't do that, but we can do it here.
Oh yeah, that's true.
Like this. So see what's going on? Because these both exist in the block and in the row, then we can isolate one, we can eliminate 1 and 2 from that. This is also true for a subset.
So
if one of them contains 2 and the other contains a subset of the 1, it's also true. Because no matter what, we know that 1 and 2 can't be anywhere else.
Wait, but in that scenario, we know that 1 would go in that spot, and then
2.
we would know that.
Yep. But I'm pointing out it's true for a subset. In here, a subset's kind of trivial. Who cares about a subset? Okay? Let's go to the next one. And the reason I'm pointing it out because it's very similar here. Advanced logic, same thing here. Now, if I have 3 squares in a row, column, or block, then I know that 1, 2, and 3 have to be in those 3 squares. Okay?
Yes.
And they're not over in here. Let's go, can I do that? No, not quite.
But you can still do that.
All right, like that. Okay, so that's my 3x3 rule. I'm calling that. Just made it up. Do you like it?
Yeah.
And this is also true if we have a subset.
So 1 and 2 here, or 1 and 3 there.
Sure.
And then even right here if it was 1 and 2.
Yeah. It's still true. These three numbers have to be here.
What if in the other one it was 3 and 2?
What, here?
There on the last one.
Oh, then we don't have it.
Okay.
I'm not sure about here.
Because 1 could be, yeah.
I think actually we do have it here.
Oh, wait,
but I'm not
we
sure
do.
how to spot that.
Because if that one ended up being 3, then that one would end up being 1.
Yeah, we still, I think the answer is yes. We have a subset of 3 numbers spread across 3 different cells and nothing else in those cells. Does that make sense?
Yes. Yes, I think it does.
We're going to have to think about how we're going to do this. So, in fact, I think we save this for tomorrow, is what we do. Because we're running up, we got about 12 minutes left in the show. But yeah, it looks like that's true. That if it's a subset, so we're looking like, let's just detail it right here so we understand what these rules are, right? Let's go new slide. We're going to call this the n by n rule. I'll make these cursive. So, and I'll make these a little bit bigger. This is the n by n rule. Whoops, I didn't want you to do that. And let's not make that. I said cursive, I meant italic. All right, so it's the n by n rule. And we're looking for basically n squares in a row, column, or block that contain, that together only contain n values and different values.
Okay.
If found, that means no other squares in that row, column, or block have those n values.
Ah. Okay.
And it's important to say only contain and different values. We can remove those as possibilities.
So, what is the 4x4 rule?
4x4 rule is the same. The 4x4 rule looks like this. I have 4, or a subset of the 4,
Yeah.
in 4 different squares.
And could these be in any parts of the block, or do they all have to be in the same? Yeah, they just have to be in the same block, right?
Same block, same row, or same,
Or same
column.
In the same. Oh, okay. And then we know that those 4 numbers. Oh. All right. All right.
Yeah. So that's what we're. If found means no other squares in that row, column, or block have those n values. We can remove those from as possibilities from the neighboring squares. This is what we're going to work on tomorrow, I think. And we'll do recursion as well as the final step if we can get both done.
I hope we can.
That's what I think. Is there anything else we want to do to talk about this? There's one other thing I kind of wanted to look at here, is that what happens if there are other pieces in here? Like here I've got a 6. But if I have, so here this is kind of interesting, right? I have, let's take this 6 and highlight it slightly differently. Take the 7, we're going to do the same. And the 8, do the same. Okay? So I've got this, but look, I've still got 4 squares with a subset. And these are only in these spaces. It doesn't matter, this is just extra noise. It still means the 1, 2, and 3, and 4 have to be here because they're nowhere else. That 1, 2, and 3, 4 are nowhere else. So this can be noise.
What if you have 2 noise elements?
Yeah, sure, still should work.
In one block.
Yeah, so as long as we got 4 in these 4. So if I come in here and I say, I change this to a 9, like this.
And then what if you change the 3 as well to a...
Let's see if we still have that. I have 1, 2, and 4. I have 1, and the thing is, all these others have to be in somewhere else out here too, right? In other words, the 6, 7, 8, and 9, the blue numbers are elsewhere, but the gray numbers are only in these 4 squares.
Okay.
Okay, so we turn this one over here. We're going to say this is a 5, like that, as a possibility. We still have 1, 2, 3, and 4 spanning across 4 squares.
But
that's what we have. And these are all possible out here. What that means is 1 is available nowhere. 1 has to be here, here, or here. 2 has to be here or here.
This rule could kind of go until you can't fit them in the block. So you can have the, like a...
Yes, you have a 5 by 5 by 5, a 5 by 5 rule as well.
And then also a 6 by 6 rule?
Right, but but I think we're getting to a point where we're over half of the squares, so I'm just not sure if that's going to bear any fruit.
Happen.
I don't know if we're going to get anything from that.
Yeah, okay. We don't have to.
But that's the thing. So we've got to devise logic, and this is what we'll have to think about between now and tomorrow, Kimball. We'll have to devise logic to collect this data, to find, possibilities, to be able to identify that pattern, and if we find it, then apply the logic so we apply it to the other remaining squares in the block or the column or the row.
So do you remember if our code, if it wait, I'm not remembering what I was going to say.
Okay. Well, if you're going to ask, do I remember if our code already does this?
No, not if it already does this, but that was something else. Okay.
Yeah, so we're going to have to find this is what we're going to have to do. We're going to have to go through, examine every square inside a row group, a row, a block, or a column, look for this pattern. I say we start with this pattern here.
Yeah, like when you're...
this one's easy to spot.
When you're simplifying a fraction, you look for, you try to divide by 2 until you can't anymore.
Right. So it's a little bit like that. Let's go for the one that's easy to catch first, which is let's find 2 pieces that both contain the same 2 values. And then remove it from everybody else.
Oh, but here's the thing. Oh wait, no, it's never gonna occur. Okay, wait. Can you go to slide number 16? Oh wait, never mind. I was gonna say, in this slide, 2 of the numbers, they have the same numbers, but then it ends up being a 3 by 3. But then it's not because they're different numbers.
Yeah, this is the 3 by 3. That's the 3 by 3 rule, even though it's only got 2 values on there. The 3 by 3 rule.
So that would never be mistaken as the 2 by 2 rule.
Right, because I don't have you have to have the exact same. Now here's the thing though, this could be mistaken as the 2 by 2 rule. Well, no, it can't because the 2's here. But if this was a 4 and 3, then that is. Yeah, it would not be mistaken as a 2 by 2 rule. It would not because.
Wait. Can you go back to that slide number 16? If at first we look for, if the first thing we do after we can't solve anymore using our other strategy, if the first thing we do is look for the 2 by 2, then it will register that as a 2 by 2. So maybe
it won't because of this 2 right here. In other words, to satisfy the pattern, not only do we have to match it here, but we have to make sure that this and this can occur in any other square.
Oh, right.
Right, is kind of the idea. Well, actually, no, that's not true. Because we could have Oh no, wait. No, this would match. This would match
Yes,
the 2 by
and then
2,
it would
but it
say
would
that the
correctly
2
match the 2 by 2
couldn't be
rule.
there.
What'd you say?
And then it would say that the 2 wouldn't be allowed to be right there.
Yes, and it would take the 2 away from here, which means this would become a 3.
So it would be correct. So that is not a subset of the 3 by 3.
Right, it's not. It is the 2 by 2.
Okay.
All right, let's go back and change it to that. Now we have the subset.
All right.
Okay? All right, buddy. Let me get a raid going over here.
Okay. I think that was a very productive show.
Okay, fine. I thought you did a good job.
Thanks. I thought you did a good job.
I thought you did a better job.
I thought you did a better job.
I thought you were the best. All right, where are we heading you to sending you off to here? I'm gonna send you to Chill Codes. Let's get you over there. Everybody have a good day. We'll see you tomorrow. We'll pick this up tomorrow, finish this up, and
See you tomorrow.
see you tomorrow.